this is wrong. You can tell me why. Yes? It should be capital letters. So when you say y is equal to 2.29 degrees, it doesn't make sense. Okay? Although I overlooked it for a few people that did that, but please take notes. Okay? What else? What else? What else? Calculator was one issue as well. Can I check some of the comments? Because some people made similar stuff, so we can. This is the minus 60. You know what I mean by this, right? Yeah. And this angle. For some of you also, there was a question that asked you to calculate area of the triangle. The one angle is 121 degrees. And I saw for most of you drawing this shape and writing 121 degrees. How is that 121 degrees? Okay, there are three questions there. What question is that again? Yeah. Question 3 of the area of triangle. I wrote word problem and you are supposed to sketch the shape and and find the area. And sketching the shape, the first two were mostly accurately done. And the third one, over 5 people did this. About 4 or more, I think, did this. And that's wrong. Okay, this is 121 degrees, so it should look like what? Look like what? An obtuse angle. You have something like this. It doesn't have to be a perfect shape. But at least we know this is more than 90. Then also, what was the first one? 49 degree, right? Somebody was drawing something like this. 49 degree. You can tell me why I think this is not correct entirely. I'm talking about question 3A. Triangle ABC, AB is 10, so maybe something like this, BC. Is angle C 49 degrees? Let's check quickly. Angle B is 49. Okay, so somebody drew something like this with angle B as 49, maybe something like this. And somebody tell me why this is wrong. Yes, Jovino?
Because C is a right angle triangle.
Nobody says a right angle triangle. Why are you drawing a right angle triangle? About 2 or 3 people did that too. Nothing in the question says the right angle triangle. So why are you drawing right angle triangle? I only give full marks for anyone that drew something like this for that 49 degree question. We never said it's a right angle triangle. So why are you assuming it's a right angle triangle? Okay? So, I think the last thing I would like to mention okay, for question okay, everybody look at question 2. For question 2, you have a shape like this. Can you give me the length of the side? 14, 13, and 12. So 14, 13, 12, like this. And this angle is what?
68.
68. Somebody use Eros formula. Waste of time. In Eros formula, you have to first find your S, then you have to substitute into some square roots, when you can just go directly into the trigonometric approach. Area is equal to half AB sine theta. What is your A and B this time around? 12 and 13. Half times 12 times 13 times sine 68. And the calculator does the rest. 1, 2, 3. 3 lines, you are done. Eros formula, you have to first calculate S, about 2 or 3 lines. Then you now state the area with square roots. Then you substitute. So you have about 6 to 7 lines. You could have just done it in 6 lines. And I always say to tell you, it's not about how many lines I have there. If you have too much line, then it's not a smart idea. It's not the smartest idea, let me put it that way. So if you have an angle, you just go to your half AB sine theta. You don't use Zero's formula and waste so much time. Understand? So I noticed that. So the sine rule one. Where's the sine rule one?
This one.
The sine rule problem. I have a comment on the question 5 that talks about strain. I'll put that here. It says a string is hung on a horizontal beam. So horizontal beam like this. Oh, a mass is hung, sorry, using 2 strings. If this is your horizontal beam, and you hang something, you know what the horizontal beam looks like, right? Maybe something like this. And you want to hang something using 2 strings to this. It means this is what your triangle will look like. Yes? If you want to be more detailed about it, in the context of the problem, you have this. One of the angles formed by the shorter whatever is 71. Of course, you know this is 90. So 71 will look more like this. Then this is 2.5. The other angle is 43. Of course, 43 will look like half of 90. So it will go this way. So I was expecting to have something like this. But guess what some people told me? Now this is 71, right? And this is 43 degrees. This is the length of the shorter string because the mass is probably here. Right? And you have to find it. So this is your x. This is what I saw in some paper. I don't know, maybe the mass is defying gravity. Are we in the space? Why would somebody draw this? Of course, to them, this is 71, this is 43, the angle facing the 43, the side is 2.5, and this is what they are looking for. So when you hang a mass, it is hung up. The mass is floating, while the beam is here. How does that make sense to anyone? I keep telling you, stop doing math like you're doing numbers and letters all the time. Put yourself in that situation. So you're telling me if you put yourself in that scientific experiment situation and you hang your mass using 2 strings, the string will be floating. Really? Come on. That was quite unexpected and disappointing. And this is the nonchalant attitude I told you should not reflect in your paper. You just want to get an answer. You don't care if it makes sense. That's nonchalant attitude. Oh, it's a triangle. I'm just going to get x like everybody. X is 2.5. That's it. How does that make sense? Your result should be in the context. When I say in the context, in the situation, it should sound like that situation. Not because you're just getting X, Y, and Z. Nobody cares about that. This is an application problem, not a direct problem. That was quite disappointing, I have to tell you the truth. Because I wasn't expecting that. I think about 2 or 3 people did that, and I'm like, come on, what is this? If there's any other question, or you missed something, check with someone and check with me later. But that is the feedback I thought I'd give to you. So quickly, because we have to do this today, the trig equation that I was doing the last time, that's what we're going to do. I have about, is it 12 or 20 questions over there? Or 16 questions? So quickly, because of our time, we only have about 30 minutes. Why is he raising his hand?
I don't have the page.
Why is somebody holding extra paper? I printed 25. Thank you. I already put some quadrant information in your worksheet. I want to explain some idea, then I show you how to use the information on your worksheet to solve this problem. Okay? Everybody please pay attention. Look at these 4 quadrants. 1, 2, 3, 4. I was telling you about the butterfly shape the last time, yeah? And this is what I mean by the butterfly shape. This is where the angle stops for the first quadrant, where the angle stops for the third quadrant. So I'm just going to draw a straight line. Okay. So if I'm dealing with the first quadrant, this is where the angle stops. Second quadrant, this is where the angle stops. Third quadrant, this is where the angle stops. Fourth quadrant, you understand what I mean? So now by butterfly shape, we are saying that we are considering this part. Meaning that for the first quadrant, this is what you are looking for. This is where you want to consider. Okay, let me put it this way. Alpha is the acute angle to consider. These are the alphas for each quadrant. Maybe I'm sounding a bit confusing, but this is what I mean. If for the first quadrant, you travel, you stop here. This is the angle of inclination. That is the alpha. Okay, let me say this is the theta. Okay, coincidentally, the theta is the alpha. Alpha is the acute angle equivalent of that whatever angle you have. What do I mean by acute angle? I can draw a right angle triangle here, and this is the angle to be considered. If I draw a right angle triangle here, it's not going to be the angle with which I travel to this line. It's going to be what is left. Are you with me? For example, if I'm doing second quadrant from the origin, yeah? Second quadrant stops here, and this is what I have. That will never form a right angle triangle. But I can form a right angle triangle here with what is left of it. Okay? If I'm dealing with the third quadrant, I'll show you this in the calculator also. I stop here, right? I can never form a right angle triangle with the entire theta. Theta is the angle with which I move. Maybe theta is 210 degrees. But there's no way I can form a right angle triangle with the 210 degrees. But if I join these together, yes, then this can give me the right angle triangle. So those right angle triangle parts are the ones that I call alpha. And if you label those parts, then it looks like you have the butterfly shape. Okay? But what do we need this for? We want to try to see some conversion equation. Let's see. For my first quadrant, I don't have issue with first quadrant. But for my second quadrant, let's start with Q2. So this is the angle, theta. Theta is more than 90. Okay? If I want to get the acute angle relating to that, it's going to be here. Is that not? So clearly, my alpha has a relationship with theta such that it is 180 degrees minus theta. Are you with me? For example, if this angle is 120, then this must be 60. Yes? Similarly, if I'm looking for this one, and I have this, hello? If I'm trying to find theta and I have alpha, I will also do the same, right? So what does that mean? It means theta is also 180 degree minus alpha. Do you agree? There's a reason I'm writing in blue and black. I'll show you why in a bit. This is for second quadrant. Let's see how this equation works in the third quadrant and also in the last quadrant. In the third quadrant, I have this. This is third quadrant. Third quadrant means I start from here, I go this way until here, right? So this angle is my theta from the beginning, right?
Yes, sir.
This I need you to, Now, using this butterfly pattern, the acute angle that I'm talking about is here. Do you agree?
Yes, sir.
Can somebody tell me the relationship between alpha and theta? If I want to find my alpha here, my alpha will be what?
Theta plus 180.
Say that again?
Theta is alpha plus 180.
I didn't ask you what is theta. Can you see the board?
Sorry.
Thank you.
It's theta minus
Please, I don't want distraction and I don't have time, all right? I don't want beating about the bush. We go straight to the point. You ask what I'm looking for. So, again.
Alpha is theta minus 180.
Say that again?
Theta minus 180.
Do we all agree with that? Class, do we all agree with that?
Yeah.
Are you confused?
Yep.
What is confusing, please?
I just.
Is this clear to you?
Yeah, but how is it minus?
Is this clear to you? Okay. Can you explain why alpha is 180 minus theta?
Because it's 180 minus theta. It's like, I don't know. It's the rest, the small angle.
Why is it 180? Why is it not 270? Why is it not 360?
Because it's on a straight line.
That's what I want to hear. Now look at this.
So shouldn't it be plus?
Plus, what is plus? What plus what I mean? Come on.
The alpha plus theta.
What are you proposing? Quickly.
Alpha plus theta.
I'm asking what is alpha. I'm not asking for alpha plus anything.
So it's 180.
Yes, Miss Justin. Can you explain why it is 180 theta minus 180?
I'm confused. I'm like totally confused.
With everything that I've been doing, or just
The
this one?
butterfly thing, I got confused.
Looking at this shape, do you get this too?
Yeah, I get that.
So even if you don't understand this, let's focus on what you understand,
Yeah,
because I have very little
understand
time.
I understand that.
So with this, can you similarly tell me what this is?
I don't understand why it's 180 minus theta.
You never said 180 minus theta. Jubino, can you repeat what you said?
So it's theta minus 180.
He said theta minus 180. You don't understand why you have theta minus 180? James, do you know why?
Because it's on a straight line and like theta is bigger than 180, so if you minus it from a straight line, you get the alpha.
Theta is bigger than 180. Isn't that obvious here?
Oh, okay.
And we are looking for this part. Isn't that the extra after 180? So if you need the extra after you have turned more than 180, how do you get it? How do you get it?
You do all of it minus 180.
What is all of it?
Theta.
Is there a problem now? Please, I need 100% focus. We don't have time. I don't want to do this tomorrow. I have something else to do with you tomorrow. So whatever that's distracting you, I need it off your mind. I need you to focus. Started this last time. I don't expect to have to repeat something for 5 minutes. Now, similarly, what if I want to find theta? If in this case, I'm provided with alpha, and I want to get the value of my theta, Corinne, how do I get it?
Use 360 minus theta.
Did you hear my question? Class, what do I want to get in my question?
Alpha.
Theta.
Theta. I thought I wrote that on the board. Theta is equal to means I'm trying to find out theta. Are you guys confused or what? Because even more than half of the class is telling me something else. What's going on? Who is confused? Raise your hand. If you don't raise your hand, that shows you're not confused. So why are we getting this response? Yes, miss.
316 minus 19.
What am I trying to find, Corinne? Theta. And what do I have? Oscar, what do I have?
Alpha.
So if you have alpha from this diagram, alpha is a value that is given, and you want to find out theta, your way of doing this is 360 minus 90 minus something you don't know. Horace?
180 plus.
Say that again.
180 plus.
Do you agree with that? Or you are not sure? Yes?
Me?
Yeah.
Agree.
I agree with.
With scares.
What about you, Natania?
Yeah, I agree.
Tomash? Zola? Megan? You agree with her? Can you repeat what she said?
180 plus alpha.
I'm trying to find this red line from here to this place. Someone has provided this. For example, this is 20 degrees. You want to know from here up to this point. Isn't that just 180 plus the extra? That's what we are talking about. So it's going to be 180 plus the little alpha that you have. Or alpha plus 180, whichever the case is. There's a reason I'm breaking this into this, because then you can understand what I printed on your paper. You don't need to know how I got it. You just need to know the summary. The last quadrant now. If in the last quadrant, you will have moved from here up to here. That movement, let's call it theta. The entire thing is theta. Give me an example of the value of theta here. Speak louder.
310.
310. Now, by this shape, when I say this butterfly whatever, I'm talking about the right angle you can form with x-axis. If you're in the first quadrant, the right angle triangle to be formed with x-axis will be here. Second quadrant, it will be here. Third quadrant will be here. Fourth quadrant will be here. I mentioned butterfly so that it's easy to remember. I don't know why that simple explanation becomes a confusion for you. And the idea is try to see the relationship between an angle that is bigger than 90 and an angle that is less than 90. That's the whole idea of what we are trying to do. Because when I asked you to check arc sine of something last time, you couldn't get the exact answer, isn't it? But this is an easy way to get the answer. That's why we need to go through this. So you need to be open-minded and try to connect with what I'm doing and ask questions and not just sit down. Now, the acute angle, which will be here, will be this one. Right? It's going to be this one. Everything is theta. So, if I want to write the relationship for alpha, what will it be? You raise your hand. If I want to write the relationship with theta, what will it be? Raise your hand. Not Jubino, not William. Tamash, pick the first one.
360 minus theta.
Are you sure this time?
Yes.
Are you very sure?
Yes.
Kiana, what do you think? Say that again. I need you to listen when someone is talking. You need to listen to everything someone is saying. Me or response. Don't zoom off and suddenly you are awake. Can you repeat what you said?
Theta, 360 minus theta.
That's what he said. Keely.
I agree with 360 minus theta.
Good. Do we all agree with that?
Yeah.
That makes sense. 360 minus theta. Okay, now I want to get theta. Raise your hand if you have an idea. Tiago.
360 minus alpha.
Oh, the same thing? Are you sure?
Yeah, I'm sure.
You're very sure. Final answer.
Yeah.
Final answer.
I'm positive.
360 minus alpha. Corinne, do you understand why? You don't try to memorize step. It is what you see that you say. If you want to get this, it is everything minus what has been written in red. And that's why you have that. And if you want to get everything, which if this is provided, it is similarly everything minus the smaller one. Now let me show you how the red part is used, which you don't need to worry about. What you need to worry about, how the blue part is used. The reverse, which is this, is what we need today. But I want to show you the usefulness of this. Now bring out your calculator. You see, the first one is used. Currently, our IB students are working on this. I think they did that the last time. The first one is used when you are only provided the angle in the first quadrant. And then you want to use that to find the angle in other quadrants. Can somebody confirm for me that sine 30 degrees is equal to 0.5?
Yes.
Okay? Now, see what I'm going to do. Use this to find, without calculator, the value of, so I'm going to use it without calculator, and you are going to confirm for me. Sine 150, because that is the equivalent of 30 in the second quadrant. When I say the second quadrant, it means the difference between them. Okay, with 180. You get what I mean? Okay, now watch this. Sine 210. And in the last quadrant, it will be 330. Now, watch this. Don't press the calculator yet. Remember, all students take what?
Take chocolate.
Template. Now, this is what quadrant? This is what quadrant? Second quadrant. Is sign positive or negative there? So this will be positive. Sine. To convert from the big angle to a small angle, I use 180 minus the big angle. Which means this is exactly the same as sine 30, which has been given as 0.5. Okay? 210 is in what quadrant? Is sign positive there or negative? Negative. So I will start with that negative sign. Then I come to the third quadrant. In the third quadrant, it says to convert from the big angle to the acute that we need in that quadrant. It's going to be the big angle minus 180. So in this case, it's going to be the big angle, which is 210, minus 180. So that is negative sine 30, right? And that is negative 0.5. Are you with me? This is in which quadrant?
4.
What is the sign of this trig ratio?
Negative.
So I start with negative again. Then I want to convert it to the acute. Okay? To convert to acute, I go to this blue again. 360 minus that big angle. Can you see that? Again, you don't need to worry about this for indices. So that's negative sine 30, which is negative 0.5. Please check all this, 1, 2, 3, your calculator, and confirm if we got this result. We got it?
Yeah.
That is how we use the blue one to evaluate trig ratios of angle around 360 degrees. To evaluate that, especially when you're only provided with the acute equivalent. Now, you are not going to be provided with sine 20, sine whatever all the time. The usefulness of this is when you do trig of special angles. It's not in your syllabus. You're supposed to know the value of sine 30, sine 45, sine 60, and their multiples. You will learn that in IB Form 5 course. When you know that, with what I've just done here, I can easily give you the sine of 600, and you're supposed to work it out without the use of calculator. You first subtract as many 360 as possible. You get to a boundary between 0 and 360. Then you use this conversion to change it to maybe sine 30 or minus sine 30. You should have known what sine 30 is, which is 1 over 2. Then it will be plus or minus 1 over 2. That's it. But the opposite of this is the solving equation. That's the reason I started with this. And that's the only thing you need to worry about. Not all this that I've talked about. Okay? Now, let's pick one of them. You can see clearly that sine of something that gives negative 0.5, there are two possibilities.